So last class we discussed about signal and sig action. So now we are going to see in detail about sig action. So first thing, what is meant by events and signals? So a running program may be interrupted by an event, which is generated by a human or by a fault, hardware fault. So if you press Control Z, Control C, that is nothing but an event generated by the human. Whereas hardware fault is nothing but divide by zero, segment violation. These are an example for hardware fault. Okay, so when such a kind of events are occurring, we have to intimate to the process through signals. Okay, so when such kind of events occurs, a signal need to be generated to indicate to the process an event occurred. Okay, once again, please. Okay, then how to intimate a signal to a process? So for that we have to make use of a signal function. So what signal a process need to handle, that you have to specify through this argument. And then when this signal occurs, a function need to handle that signal, right? So we have to specify a function to handle this signal. So when an event occurs, a signal need to be generated to indicate to the process that an event occurs. A signal can be generated by using the signal function. You have to specify what signal the process should handle and which function to handle the signal. So when this signal occurs, what function to handle the signal, that we have to specify. So for to write the signal handler function, the format is this one. So you have to specify the signal handler function name with the signal number. Return type is void. So this is what we discussed in the previous classes. So here in this program want to handle sick child. Okay, so this is the signal which this process want to handle. Okay, so when this signal arises, this function is called that is going to handle this signal. So this is the function which is going to handle the child event. So when the child process terminates, it sends the child event to the parent. Sorry, child signal to the parent. So when this signal arrives, this function is called. So this function is going to handle this signal. So this function routine here, just a definition. Function definition is given here. So when you are executing this program, it is a fork system call. A child process will be created. So this is parent part will execute and this is child part will execute. So first parent is executing. So parent ID will be printed. After that, child is executing. Child ID is printed. See the output here. Child ID is printed. Then child terminates by executing exit of 0. So now the child is terminated. So when the child is terminated, it will inform to the parent through this signal, this child. So it means the child is terminated. So now this signal is generated. So this handler will be called. So control goes to this handler. So here we are printing PID of the process. So which process terminated? That process ID we are printing. So wait of null is nothing but it is the wait system call. Here by using this system call, the child is waiting for the parent here. So you are getting the process ID. Then process ID percentage exited. So the terminated child process ID you are printing. So PID child process number exited, like that you are printing. So this is sick child event. Okay. So sick child is nothing but when a child process stops or terminates, sick child is sent to the parent process. Then wait system call. On success, process ID of the terminated process will be written. On failure, -1 wait will be returned. Now coming to the sig action. So what we discussed is only signal. Okay, now we are going to discuss about sig action. So in sig action, what is the difference between signal and sig action? In case of signal, does not block other signals from arriving when the current handler is executing, whereas sig action block other signal until the current handler returns. So meaning that If you registered a signal to be handled by a process, only that signal is allowed. Other signals are blocked in the case of SIG action. So when the process is handling a particular signal which is specified in the program, only that signal is allowed. When you are invoking other signal during the execution of that current handler, the other signals will be blocked in the case of SIG action. Whereas in the case of signal, more than one signal is accepted, not only the registered, other signals also accepted while you are executing the current handler function. Okay, that is the meaning. Okay, so SIG action blocks other signal until the current handler returns. Whereas signal will block will not block other signal from arriving while the current handler is executing. See here in main program. So this is the registered signal, sick child. So only it will accept, this process will accept sick child. So this is by using signal. Okay. So this is by using signal. So we are registering sick child need to be handled by the process. So this is the signal have to be accepted by the process. Here we specified signal function. So means that you can also issue other signals. Okay, if you specify signal action here, then only sick child is allowed. Okay, when the current handler is executing. Okay, so this is sick child event. So here fork system call child is created as usual. So parent is first printing and child is printing its ID. Then it is exit of 0. So sick child event occurs. So the control has to goes to handler function. So when the current handler is executing, see here, I pressed Control C. Okay. So here I pressed Control C. So actually this program has to accept only six child, not other signals. Whereas it is a signal system call, so it accepted Control C when the current handler is executing. So it terminates the process. So when the current handler is executing, okay, I pressed Control C. Immediately the process terminates without printing the statement. So if you use signal during current handler execution, if you press any other signals, that is also accepted. Or it clear up to this if S type single S in the comment section. Okay. Now coming to SIG action, same program. See here, this is by using SIG action. So first thing here for structure SIG action, we are creating one variable. So one structure is called SIG action. We are creating one variable for that structure. Then the structure having some members, right? One member is handler and another one is flags. So here for the handler you are assigning handler as the name, that is this one, the function name. Okay, this function name. I will tell you what is the meaning of this one after this, after this program. So here you just see this statement, it is SIG action compared to signal. Which is signal it can accept only SIG child. Okay. And this is address of new app and this is null. I will tell the meaning later for this one also. So here this process can accept only SIG child. That's the meaning, right? So here again a fork system call is created, called. So parent process executing and child process executing. See the parent process executing, it prints its ID. Then child process executing, it prints its ID. After that child terminates. Once child terminates, it generates the SIG ID. It generates the SIG child. Okay, it generates SIG child. So after invoking the SIG child, this handler has to execute, right? So this handler, see here, it prints the ID. Terminates process, it will keep on printing as it is while of 1, it will keep on printing PID. The terminated child process ID will be printed. Keep on, it will be printing. I pressed Control C. Okay, when the current handler is executing, it is not accepted because it is a SIG action. So when the current handler is in execution, other signals will not be accepted by SIG action. That is the meaning. So here I pressed Control C during this current handler execution. It is not at all accepted. Okay, so that is the usage of SIG action. It blocks the other signals while the current handler is executing. Now we'll see what is the meaning of this function, SIG action. What is the format? So you have to include this header file, SIG action, signal number which you want to handle. Okay, that is here we specify SIG child, right? So which signal you want to handle? That is the first argument. That is the first argument. After that, here you will be having two sets. One is const struct SIG action act, and this is the same struct SIG action old act. So this is new act and this is old act. So which signal you want to block, that you can specify in these two variables. Okay. So here these two variables are used to specify which signal you want to block. This is the new set and this is the old set. Okay. Then so the first argument signum specifies the signal and can be any valid signal except SIGIL and SIGSTOP. So the signal number is nothing but you can specify any signal, okay, which process want to generate, which the process can accept. That is the signal. Which signal you want to block, okay, that you can specify in new act. Suppose already you have a list that is there in old act. That is the meaning. Suppose assume that I want to generate only the process can accept six child event, that we can specify here. Six child event need to be handled by the process. We can specify here. Suppose I want to specify it should not accept um, sig int. So in that case, I can specify sig int here in this set, new act. Okay. And in the old act, already it may have some signals that need to be blocked. So which signal you want to block? Okay, that you can specify in this variable. So already you have a set of signals to be blocked. That will be there in the old act. If you want to, additionally, if you want to add few more signals, after adding, it is there in the new set. Okay, the signal which is accepted by the process have to be specified here. We'll show an example. Before that, what is the meaning of struct SIG action? So here we are using a parameter struct SIG action act, struct SIG action old act. See here, it is a structure, SIG action structure, which consists of three members. One is handler, another one is mask, another one is flag. Okay, so this is the handler, mask, then flag. Okay, so this one is for to specify the signal handler function. Okay, when an event occurs, the signal need to be handled by the handler. So that handler we can specify by using this one. And this one is for signal to block during handler. So during handler, what signal you want to block, that you can specify here. Then flag, it is an optional one. You can specify the option. So these are the signals which we can generate through keyboard. Control C, Control Z, Control slash. Already you are familiar. Same thing. Now see here, struct the SIG action new actor. So for this structure, you are creating one variable called new actor, and then structure variable dot SA handler. So structure variable dot, this is the handler, right? So SA handler is the member of that structure. So structure variable dot SA handler is equal to quit. So quit is nothing but name of the signal handler function. See here, quit is the name of the signal handler function. So structure variable dot the handler function SA dot handler is the member of the structure is equal to quit, meaning that when the signal raises, you have to call this quit function. That is the meaning. After that, structure variable dot SA flags equal to 0. The structure variable dot flag is equal to 0. That's the next member. SA flag. Okay. Is equal to 0. Then SIG action we are calling. which signal the process can accept only SIGINT. Okay, and have an assumption we have not specified any signal to block new act. Okay, and in old act is also null. So new act and old act both are null. Okay, so only the process can accept control C. That is the meaning. Okay, so SIG action. SIGINT means control C. So only this process can accept control C. And here we don't have any values. So after that, this is a for loop, indefinite for loop. You are printing the value of dot. That's it. It will be keep on executing. See here, see the output. It will be started to print dot. I pressed Control Z. It will not be accepted by SIG action. Which signal it can accept? Only Control C. So it will be keep on printing dot. When I pressed Control Z, it will not accept. When I pressed Control C, immediately the process terminates because this process can accept only SIGINT, Control C. After accepting Control C, where the control has to go, it has to call the handler. That is this quit program, quit function definition. So control goes quit signal handler function. So what will be the code? It is SIGINT. So the value is 2. So you are printing interrupt. What is the code? It is 2 and the I value. In which I value it is interrupted. Okay. So in SIG action, only this signal is accepted. Okay. So when you press other signals, Control Z, this program will not accept it. Only when you press Control C, it is accepted. So it calls the handler quit because here we specified the handler is quit. So structure variable dot SA handler is quit. We specified. So control goes to this quit. Then you are executing this function definition. If you are clear up to this, type double S in the comment section. Then here same program. So here I am adding the signal. See here structure SIG action new action. So we are creating one structure variable. First I am emptying the set new act dot SA mask. So the signals to be blocked will be there in SA mask, right? So we are just emptying the set. Then you are adding the mask 6 stop. That is Control Z. Okay. Control Z you want to block. So that information you have added into the mask. So mask is nothing but which signal you want to block, which signal the process want to block. That signal is called mask. So 6 stop you want to block. So you have added into this variable. Now you are it's the same thing. For the handler you are calling quit function and the flag is set to 0. Then here we are calling SIG action. See which signal the process can accept. Control C. Here the signal to be blocked is there in new act. So new act 6 stop is there. Okay, and the old act is null. So this process want to block sorry this process want to block 6 stop. Okay, and it can accept only SIGINT. That is the meaning. Same program, just I have included new act as 6 stop. Okay, so when you are executing again, it is an indefinite loop. It will be printing dot. When I press Control Z, it is blocked, right? So 6 stop. So it will not accept. So when you press Control C, this process accepts SIGINT. So control goes to the handler quit. So quit control goes here. You are printing interrupted code is 2 and the word's value of I. That is printed. So here explicitly we are specifying which signal we want to block through this variable new act. So in new act mask field we are setting 6 stop. See here signals to block during handler that you can specify through this structure member SA mask. So new app dot SA mask set to 6 stop. So this signal need to be blocked. Like that we can specify by adding it to the set. If you are clear up to this, type singulars in the comment section. Okay. Next one, six set jump and six long jump. So already we discussed about set jump and long jump, right? So it is a non-local jump. So we'll be having two type of jump. One is local jump and non-local jump. Already we discussed, right? In the previous slide. So label is the jump between within a function. So it is a local jump. And long jump is a jump, non-local jump. That is to jump between the functions. That is already you are familiar with this one, right? Now coming to six set jump and sing long jump. Working is same, similar. Okay, just you have added sig in front of the words set jump and long jump. Okay, so first thing declaring jump buffer environment, that is the difference. And in the signal set, then you are emptying it, that is signals to be blocked, that you are emptying, then you are adding, which you are adding, six stop you are adding, that is control Z to the mask. So through this structure will be block process. So the signals to be blocked by the process six stop. Then structure variable dot handler is equal to which function you want to call me. So name of the handler is call me. So structure variable dot SA handler. So first thing here we have declared a variable structure sig action variables. We have declared a list of type sig action. We are creating a structure variable for the structure. Then you are emptying the mask set. Then you are adding which signal you want to block. That signal you have added here. Then which function we have to call, which handler function we have to call, that we are specifying. So call me is the function when a signal arises by the process. So structure variable dot handler is equal to call me. So this is the function to be invoked when this signal is present. Then you are setting SA flag equal to 0. Okay, structure variable dot SA flag equal to 0. Then you are calling sig action. This is the only signal which is accepted by the process, comma new action. So new action can contain six stop to be blocked. It is six and comma 1. So usually when you are invoking this function, it returns 0 for the first time. When you are invoking for the second time, whatever value you are returning through this, that will be assigned to this one. Procedure is same. Set jump function, long jump function. So set jump function returns two value. When you are invoking for the first time, it returns 0. When you are invoking for the second time, it returns the value which is passed by this function. Okay. So set the function, set the value 0. So it is not equal to 0. Control comes here. Return from first time, 6 and sum is called. So it is printing first time. Okay, when this one returns 0. So this will be called. Then when it is executing, we have set the value 6 z equal, so this one prints. After that I am pressing Control Z. So this signal is blocked by this process. so it will not be accepted. Then when I press Control C, immediately the handler will be invoked. Which handler? Call me handler. So sig stop is not accepted by the process and the Control C is accepted by the process. So control goes to call me function. So this call me function prints catch signal and value is printed. After that it is long jump. So control where you set the set jump to that function the control returns. That is here. So value 2 will be written by this 2 stick long jump. You have to specify the environment variable and then two parameters it takes. Environment variable save mask and then here environment variable value. So in long jump you will be having two parameters. One is END and another one is value, return value, right? So END and then return value. And this one ENV variable comma save mask. So whatever you have the mask value, process to block the signal that you can save it by using this variable. That is the meaning. So save the environment, jump, save the environment including the signal mask. That is the meaning. So ENV for to save the environment and for to save the signal, it is save mask. So if save mask is non-zero, the calling process signal mask and scheduling parameters are also saved. Okay. So set jump, first is environment and then save mask. You are saving the environment along with the signal mask. That is the meaning. And long jump, the format of long jump, environment variable, comma the value to be returned to the set jump function. So same thing. env is a variable to store the environment, save mask to store the mask in value which you want to return through sig long jump to the set jump function. So set jump function, first time it's returned 0, second time whatever value you are passing through this function that will be assigned to this function. So in sig action we know three members are there, handler, mask and flag is there. So in this program, same program, so first thing you have to create env variable, then a function to be handled, signal handler function we specified. For struct sig action we created the structure variable. First you are emptying the mask, the signals to be blocked. That is you are emptying, then you are adding the signal that is to be blocked, sig stop. Then this is the handler which you want to call. So structure variable dot handler is equal to call me. So this is the function need to be called when this signal arises, when the flag is and then the flag is set to 0. So we are invoking sig action. So only sigint is accepted by the process. Other signals which you specified in this variable will not be accepted. So in this case, sig stop control z should not be accepted by this program. And then you are calling sig set jump env. So when you are calling this for the first time, it returns 0. So this condition fails. The control comes here. So return from first time sig set jump is called. So that will be printed. Then when I'm executing, when I'm transferring control, when I press Control Z, it will not be accepted. If I press Control C, it is immediately accepted. So this call me function is invoked. Control goes to the call me function. You are printing the signal number, then you are returning sig long jump with the value 2. So 2 will be returned to this function. It is not equal to 0. So return from signal interruption will be printed. Are you clear up to this? If so, type double S in the comment section. Okay. We'll stop here. We'll meet you tomorrow. Take care. Bye. Thank you.